Hi everybody, thanks for watching this video today. We are doing section 4.4. We're solving quadratic equations by completing the square. If you haven't yet, go ahead and pause the video. I'll let you go over the starter on your own, just kind of listing some of the strengths and weaknesses, what you think of the different methods we've done so far. So unpause the video when you're done. Okay, number one, we are on our fourth different method for solving quadratic equations called completing the square. Only one more to go after this. It's called the quadratic formula. Completing the square, just to be 100% transparent, I don't know if it's anybody's favorite method. It's kind of a long method, and people usually choose other ones, but we'll still go through it. You might like it. You never know. So, number two now. Our last two methods for solving these quadratics can be used to solve any quadratic equation. Probably one of the weaknesses you wrote just barely on the starter for factoring was that you can only use it if the quadratic equation can be factored, and some can't. So these last couple of methods that we'll be learning over the next couple of days, they can be used to solve any quadratic equation. Here are the steps for completing the square. I think I'll just drag them all out. And then you can copy them down. In class, I realized there's something I need to add right here to step 2. So that goes on with step 2. So maybe just pause the video again, write the 4 steps down in the space provided, and then unpause the video when you're done. Okay, now that you've got those steps down on your paper, let's just practice some examples. So example 1, we've got x squared minus 18x equals negative 17, and we want to solve that thing. First step, I believe we're already in the right form. It's already in the form x squared minus or plus bx equals the c number. So step 1 is already taken care of has already been taken care of for us here. So step 2, we need to figure out what this mystery number thing is going to be. And that's just my vocabulary. I don't think the book calls it the mystery number, but you take the middle number, just like you wrote down on your steps a second ago, and first of all, you cut it in half. So negative 18 divided by 2 is negative 9. And then you square that thing. So negative 9 all squared is a positive 81. So our mystery number is going to be a positive 81. And we're going to add that to both sides of the equation. So I'm going to have x squared minus 18x. And then you put that plus 81 right there equals negative 17, and then you add the 81 onto that side of your equation as well, which is totally fine in math. You can add a number to both sides of your equation as long as it's the same number. Now, why do we do that? Why do we add the mystery number to both sides? Well, what it does is it takes this left side, and even if you couldn't factor it before, it should now be factorable for you. That's the whole point of this completing the square thing, is it takes something that maybe couldn't be factored, and it will allow you to factor it. So x squared minus 18x plus 81 would factor into x minus 9 and x minus 9, which this is step 3 from the steps that you just wrote down. Negative 17 plus 81 is 64. There's an easier way to write x minus 9 times x minus 9. It's a perfect square, so you can just write it as x minus 9 all squared equals 64. So that's step 3, you factor the left side. And then step 4, now we can finally solve. We'll use the square root property to do it. So x minus 9 equals positive or negative, don't forget the positive or negative, 8. And then last but not least, we'll have to get this 9 over to the right side. And remember, this does represent two different answers. So I'll write the two different answers out here. Positive 8 plus 9 is 17. And then negative 8 plus 9 is 1. So our two answers are x equals 17 and x equals 1. And remember, if we were to graph this quadratic equation, these would be the x-intercepts that we would find. So that's example 1, giving you a little taste of those 4 steps using to complete the square. Example 2, 2x squared plus 12x minus 10 equals 0. Step 1, we've got to get it in the right form. So first of all, we need this 10 to be over on the other side. So I'll add the 10 to both sides. Get it over to that right side. And then we need this x squared by itself. If you notice on your steps, it doesn't say a number and then x squared. It just says x squared. So we're going to have to divide everything by 2. And it'll be x squared plus 6x equals 5. And this is a good example of where you're forced to use completing the square. If you go back up here, this original equation, it won't factor, like it just doesn't factor. So then we're forced to use this new method completing the square because we can't use factoring. Okay, the mystery number. I got to take positive 6 and cut it in half, and then that'll equal 3, and then I've got to square that, so that will equal 9. So I'm going to add that mystery number, that 9, to both sides of the equation. Now, if we did our job right, this left side will factor at this point. I believe it'll be x plus 3 and x plus 3. I'll save a little writing and just go ahead and write that as x plus 3 squared. That'll equal 14. Cool. So we did step 3, step 4, solve it. We'll do the square root property to solve this thing. So we will have x plus 3 equals positive or negative square root of 14. The square root of 14 doesn't simplify at all. Now we need to subtract this 3 over to the other side, and we will have gotten x by itself. Now, this is one possible way to leave your final answer. That's called exact form. You leave it in square root form. The other way to do it is to get a decimal approximation for it. So I'm pulling my calculator out right as we speak, and I'm typing positive square root of 14 minus 3, and I'm getting the decimal approximation for that. It looks like it'll be x equals 0.74. And then I'm pulling out my calculator again. Negative square root of 14 minus 3 is what I'm typing. And I get x equals negative 6.74. I think our book kind of favors the decimal approximations. but a lot of books will have you leave it in exact form. So I'm kind of showing you both ways. Once again, we couldn't have solved this quadratic equation any other way because it didn't factor. You can't use the square root property on it right away. You had to do completing the square. So even though it's a little messy, sometimes you got to use it. Once again, too, if you would have graphed this, you'd see the x-intercepts are really at 0.74 and negative 6.74. Okay, example 3. X squared minus 5x equals 8. This one is in the right form for us. So if we find the mystery number right off the bat, we've got negative 5 over 2. Take the b number, cut it in half. So that's negative 2.5. And then you square that, and you get positive 6.25. So even though it's not the prettiest number, that's our mystery number. It's 6.25. So we're going to add it to both sides of the equation. And now this left side becomes factorable. Now you might be saying, well, I don't know how to factor with decimals. We've never really done it before. 6.25 kind of is like, yeah, that looks yucky. Real quick, let's pause on that and let's go up to these other examples and see if we can figure out a pattern. Look at this number right here where my cursor is. When you cut the b number in half, in this example we got negative 9. Look what happened to the factors down here. It ended up being a negative 9. Example 2, when you cut the b number in half, but before you square it, you got positive 3 here. Look down here, when we factored, we got a positive 3. So that can be a little pattern for you to look out for, especially if the numbers are a little messy. Whatever the b number is, cut in half, that will be your factor. So in this case, I'm looking right here, negative 2.5. That's how this thing will factor. So it'll be x minus 2.5 squared equals 14.25. Final step, solve it out. So doing the square root, we'll get x minus 2.5 equals plus or minus the square root of 14.25. Add that 2.5 to the other side, so x will equal plus or minus the square root of 14.25 plus 2.5. Let's definitely get the decimal approximations for this one. So picking up my calculator, typing in positive square root of 14.25 and then plus 2.5, I get 6.27. My other one, now I'm typing in negative square root of 14.25 plus 2.5, and I got negative 1.27. So those are my two answers for x. I had one more example, but just to keep the video to a decent length, let's skip it and go straight down to number 4. Another thing completing the square for is good for is turning a quadratic equation from standard form to vertex form. Go over the steps as we do some examples. So a few weeks ago in class, when we were looking at the different forms of quadratic equations and graphing them, we didn't have the skills yet to do standard form to vertex form. Now we have the skills with this completing the square stuff. The one major difference is instead of a 0 on one side of the equation, you're going to have a y. But for the most part, the steps are still the same. So I'll go through this first one. We need that 4 to the other side. So it'll be y minus 4 equals x squared plus 2x. Now we're in the form x squared plus bx. We can find the mystery number now. So think about this one in your head. We take the middle number, the b number, cut it in half, so that'll be 1, square it, which would still be 1. So our mystery number is 1. We're going to add that to both sides of the equation. So hopefully, if we did it right, we just made that factorable. X squared plus 2x plus 1 would factor into x plus 1 times x plus 1, which I will write as x plus 1 squared. On the left side, we'll get y minus 3. And remember, at this point, we're not trying to solve, so we won't do the square root. We're just trying to get it into vertex form. Vertex form would just be when we add this 3 back over to the right side. And there's vertex form. So now we have the skills to go from standard form to vertex form. Vertex form, you probably haven't thought about it this way, but it always has a perfect square in it. So that's why we need this completing the square stuff. So if you were graphing that, you'd say, oh, hey, the vertex is at -1, 3, and then you can just graph it up pretty easily. So sometimes it's nice to be able to switch those into vertex form. I think that's where we'll stop on the video. Just a couple different examples of each. Like I said, completing the square, not usually most people's favorite thing, but it works. It totally works. So thanks a lot for watching. Hope you are back in real class soon, and we will see you next time.